All right, we're going to do a couple of hints here. Let's go through problem number 1 first. Maybe how to find it. Okay, so here are some TVs. You're picking 2 TVs. You get to choose 2 TVs and take them home with you. Are you going to pick the same TV twice?
No.
No. So is it with replacement or without replacement? Without. Because once you take one, you're not going to put it back and take it again. Once you take it, you're keeping it. You know what I'm saying? You're selecting 2 TVs. You're taking them. So, here, let me draw a tree. I think it'll be easier. So you either pick a defective one or a good one. What's probably its defective?
2 out of 7.
2 out of 7. What's probably its good?
5 out of 7.
5 out of 7. Good. Now, I only care about the good. I want both working, so I only care about the goods. So we'll just focus on that part for now. So if I pick a good one, for my second one, what can I pick? I could be defective or good. Everybody on board?
Yeah.
So if I'm here, how many TVs do I have left?
6.
6. Everybody on board? How many of them are defective? 2. So 2 out of 6 defective. How many are good? 4. 4 out of 6. I want the probability that both work. I want to know this probability right there. How do you find it? Yes? All right, what's that probability? 5 out of 7 times 4 out of 6. 20 over 42. So it's just less than 50%. 0.4 what? 0.476. Great. What's probably that at least one does not work? So instead I'm going to do 1 minus probability that none. And then I'm just going to copy this part over. Does not work. None does not work. Then it gets harder. Because I got to figure out what that means. None does not work. So you got to just copy it over, right? Write down none instead of that, and then verbatim, does not work. Write it down just like that. Then you have to figure out none does not work. What does none does not work? None don't work. None don't work. None don't work. So none are broken. None are broken. Oh, they're all good. Right, but you have to go through that whole thing, right, and think through it. Right? So none don't work means that none are broken, none are broken, all are good. Make sense? So, what was that? It is. It's a total, you got to really think about that. So, that's equal to 1 times probability that they all work.
None does not work.
Yeah, none does not work.
It's a double negative.
It is. Right? That's the problem with this thing, is that whenever you get the all and the none, you're going to get some of this none, you're going to get some that are going to be double negatives. Right? That's kind of the nature of it. So, we already have the probability they all work. 1 minus 0.476. 5.524. Good? Yeah?
Do we have to do that for every at least one?
Yes.
Oh, do the
every
line
time
thing
you have at least one, it better be 1 minus something.
So we don't have to do the thing you just did with the words?
Yeah, you might. I don't know, it depends.
So
it might be probability that the pencil is red. The probability the pencil is, at least one is red. The probability that none are red. That's a little bit easier, right? Yeah, probably not. If I do I'll try not to on the exam. I'll try to not have a not, because it is a little bit tough, huh?
You might be asking the same question, so we're writing that's part of our explanation.
Do you have to have that? No, but you should have at least 1 less probability that something, and then I need this in there. Well, you can just put this. If you just put this, that's fine.
With no P, you don't have to go P.
Yeah, you can probably get away without that, yeah. But you better not just give me this. I better know where it came from, at least. Yeah. That's probably the bare minimum I would take. Yeah. All right, so let's take a look at problem number 2. 3. So I'll look at 3 first. So we're looking at a tree. No, probability tree. Yeah. Probability trees are always happy trees. So I said make the first one gender. So we have male and female. What's the probability that they're male?
34 out of 58.
34 out of 58. What's the probability that someone's female?
24.
24 out of 58. Good. Now, if I'm here,
You pick soccer.
that means that they're definitely what?
Male.
Male. How many of them are there?
34.
34. So everything else that better be out of 34. Do you guys see what I'm saying? You have 34 people left. And some of them will be playing soccer, some will be playing basketball, some will be playing tennis. But you only have 34 people. So they all better be out of 34. Everybody kind of follow that? Does that make sense? All right, so that's enough of a hint there. I'll let you guys figure that one out a little bit more in a minute. And then I'm going to give you guys another hint about this one. Okay, so here, we didn't go over everything quite like this one in class, but it is a really good application of this probability tree, which is why I wanted to put it in here. So here, you can either have the disease or no disease. What's the probability that you have the disease? That you have the disease? 3% has a disease. So 0.03 has a disease, which means what percent doesn't?
0.97.
0.97. Now, if you have the disease, you can either test positive or you can test negative. Testing positive means you have it, or they think you have it. Testing negative means they think you don't have it. If you have the disease, you want to test positive for it, because if you have it, you want to know you have it. If you don't have the disease, you want to test negative for it because you want to think you don't have it. You want to know you don't have it. So, let's see. So the positive, I'll let you guys figure out what you think those are. And I'm going to give you guys 3 more minutes to work on problems, on these 2 problems we just went over. I'll give you some hints on.